Hi guys, welcome to another AS Pure paper for April. Okay, so the first question requires you to know about the nature of roots and of quadratic equations, and all about this thing called the discriminant, which is often given the symbol capital delta, and to know that if this is greater than 0, that means there are two distinct real roots. That's the case that we're looking at now. And just to mention that if discriminant is equal to 0, that means that there are two same real roots. So there's two roots and they're real, but they're both the same. And if delta is less than 0, then there are no real roots. There are complex roots, but we don't deal with that at AS level. So we're asked, when does this have distinct real roots? And that's obviously going to be the case when it's greater than 0. So what is del? Well, del is that bit inside the square root of the formula for working out the roots of a quadratic. So that's going to be b squared minus 4ac. So in our case, that's going to be 3k squared minus 4 times 2 times k, which is 9k squared minus 8k, and we're requiring that this be greater than 0. So there are two cases. Either k is greater than 0, in which case we can just divide by k here, and remember that when you divide by a positive number in an inequality like this, the inequality, I shouldn't write that, it looks like it's saying it's equal, less, greater than or equal to. If you divide by a positive number, the equality doesn't change direction, but if you divide by a negative number, it does. So if we assume that k is greater than 0, we just divide by k, and we get that k is greater than 8 over 9. And the other case, if k is less than 0, then dividing it switches the sign, and so you get that k is less than 8 over 9. But in this case, we've already seen that k is less than 0, so actually this gives us that k is less than 0. So there's two cases. Either k is greater than 8 over 9, or k is less than 0. So there was the intermediate stage, but because to have anything less than 0, greater than 0 would have contradicted this assumption here, this case only reflects k is less than 0. Okay, so the next one is an expansion. So this, remember, is in the formula booklet. And in this case, so we'll have something of this form, b1 plus b2 all to the 5. And that's going to be equal to, b1 to the 5 plus b1 to the 4th, b2 plus b1 to the 3rd, b2 squared plus b1 squared, b2, etc. Sorry, b2 cubed plus blah, blah, blah. And we're told that the coefficient of x is 5. So that's when some combination of b1 and b2 exists such that the x squared cancels with the x's, leaving only a single x. So when will that happen? Well, it's not going to happen here in the first one, because that's just going to be 1 over ax all to the power 5, which is 1 over x to the 5. It's no good. This is going to be x squared over x to the 4th, which is 1 over x squared, which is no good. This one is going to be x to the 4th over x cubed, which is x. So that's the one we want. And then this one is going to be x to the 6th divided by x squared, which is x to the 4th, which is no good. So none of the other powers are going to work. It's going to be this one only. And so in our case, b1 is 1 over ax, and b2 is 2ax squared. So the coefficient of the x term is going to be 5 choose 2, which is also given in the formula booklet, times 1 over ax cubed times 2ax squared all squared, and that's equal to 5. And so you can crunch this through yourself, just putting in the 5 choose 2 and solving. So this is equal to 5x, sorry. And then you just solve for a. Okay, question 3. So we've got this inverted cone and water flowing into it. And you want to, the first question is asking you to express the volume of water in the container in terms of H. Well, that's pretty easy because they've told you what the volume of a square pyramid is. So the water forms a smaller square pyramid of base area 1/2 h squared. So the area of the base is 1/2 h all squared. So therefore the volume is 1/3 times that area, which is 1/4 h squared times h. So this is 1 on 12 h cubed. Okay, so now we're told something about how this volume is changing. And specifically, we are told how the height is changing. So we're told that there is an incoming amount of water at 20 cubic centimeters per minute. And so we have dV dt is equal to 20. But we can also differentiate this expression we found, h cubed on 12, to get the rate in terms of h. So it's 1 on 12 d dt of h cubed. And then you use the chain rule here. That gives you 3 on 12 h squared dh dt. And so you can see that dh dt, because this whole thing is equal to 20, is 80 on h squared. So you see it depends on h. So the volume is changing at a constant rate. But the height, obviously, later on, the height is going to change less each minute because it has a greater, as h is increasing, you get a less and less return as you fill the thing up. So it depends on h. And you can see it depends inversely on h. So, if h doubles, this thing divides by 4. So they're asking you to evaluate this at some specific time, some specific height. H is equal to 10. So that's just 80 over 100. Okay, question 4. So here we have some funky diagram here with a triangle and some sort of arc lengths of circles and so on. And they want us to think about the angle CBD, so this angle here. And the way to do this is to think about the triangle. So let's first find this angle here, which I'm going to call phi. And I'm going to call the angle we're looking for theta. And obviously, once we have phi, we can find theta because it's just 180 degrees minus, pi radians minus phi. So this triangle here, I'm going to sort of rotate it so that this is the 2 pi on 7 radian angle, and this is 8, we're told, and this is 8. And so this base here is the point CB, and we want this angle. So you see that this is an isosceles triangle. So therefore, the angle, so that's A, so the angle ACB must be equal to the angle ABC, and they must both equal pi minus 2 pi on 7 over 2. So there's 2 pi on 7 is taken up by this angle here. There's got to be pi radians in a triangle, and the rest of the radians are divided up equally between these two because they've got to be equal. And so this is 5 on 14 pi. And then that gives us that theta is equal to pi minus 5/14 pi, which is 9/14 pi. Okay, so now they want us to find the perimeter of the shaded region. So there's a few lines that we have to think about. Firstly, we've got this arc length CB, and that's an arc length of some bigger circle that carries on like this. So that's very easy for us to find. And we know that that is going to be r times the angle. So the radius of an arc length given in your formula book is the radius times the angle that subtends that arc length. So it's just r times theta. So this is going to be 8 times 2/7 pi. Remember that in this formula the angle has to be in radians. So I'll just write that down here. Arc length CB is 8 times 2 pi/7, which is 16/7 pi. And then let's think about CD, the sort of bigger arc length of some circle with this radius. Well, we want to know what this radius is. So if we look again at our triangle, there's a few ways to do this, but let's think of our triangle that we had before, where this was the 2/7 pi. That was it, right? 2/7, yeah. 2/7 pi, and then we worked out that each of these ones in the bottom was 5 pi/14, 5 pi/14. And we want to find this isosceles length. So we can use the sine rule. So that's the sine of some angle divided by the opposite length. So here, whoops, we want to find this length CB. So divided by CB is equal to the sine of some other angle, 5 pi/14, divided by the length of the side opposite, which we know is 8, because we were told that this is 8 and this is 8. And so this gives us that CB is equal to 6.942 centimeters. And CB, well, that's the same thing as DB, right? Because they're both radii of this larger circle. So this is equal to DB, which is another piece of our perimeter. Now we also want that little arc that goes like this. Well, that's going to be the radius of the circle multiplied by the angle. So that means that like arc CB, not the straight line CB, is going to be this radius, which we found, 6.942, times the angle that's subtended, 5 pi/14. Oops. And so I'm going to give that's the arc CB. So let's see, what do we have so far? Oh, we already found that. So that was the arc CB. We know DB because that's the radius of the triangle, and then CD is going to be, sorry, what we actually want is arc CD, which is going to be that radius times 5 pi, times 9 pi/14. Sorry, I keep getting confused with these angles. So 2 pi/7. So what am I doing here? I'm taking that radius that we found, which is this radius here of this bigger triangle. And I'm getting CD by multiplying it by theta that we found, which is 9/14. I got the DB by just getting the radius, and CB we get from this other circle. So yeah, this was 5/14. Apologies for the confusion. So the full perimeter, oops, So the full perimeter is going to be the radius of that which is dB, the radius of that bigger circle, plus the line CD, plus the arc BC. And that'll be 28.1. Okay, question 5. So here we've got some a plot of some trigonometric functions, and we're going to be using our knowledge of trigonometric functions and our knowledge of graphing in the Cartesian plane to solve this thing by calculation. So if you look at this first line, this is the line y is equal to tan of x, and this other line going down is y is equal to cos of x. So if we want where they cross, we just set those y coordinates equal to each other. When are they equal? Well, so when is tan of x equal to cos of x? We know that tan of x is equal to sine of x over cos of x. So if we multiply both sides by cosine of x, we get that sine of x is equal to cosine squared of x. And we know that cosine squared of x is equal to 1 minus sine squared x. So we get that sine squared x plus sine x minus 1 is equal to 0. And we're going to solve this for as a quadratic in sine of x. So we get sine of x is equal to minus 1/2 plus or minus the square root of 1 plus 4 all over 2, which is going to be equal to either minus 1/2 plus square root 5 on 2, or minus 1/2 minus square root 5 on 2. And you'll notice that this one up here, well, this is this one below is less than minus 1. So therefore it is not allowed, because sine of x only ranges between minus 1 and 1. So this one is the only value. So therefore x, if you plug that into your calculator, you get that x is equal to 0.666, the x coordinate of A. This is obviously just the first of, so this is radians, by the way. This is only the first of the available solutions, which makes sense, right? It's a quadratic. It's a trigonometric function, so it's going to be periodic. So there's going to be several places where there's going to be an infinite number of places where sine of x is equal to this, just going to oscillate between them. And obviously we're going to look at 2 of them. We've already got A. That's the one our calculator has given us. But now we're going to find B. So we know that the trigonometric function looks something like this. And so if we get 0.666 radians somewhere there, then there's another value over there which will also fulfill our, will give us the same sine of x. And does that lie within our range? Well, x has to be between 0 and pi. And that's fine because pi is over here. And so there's 2 values within that range which will give us the same sine of x. So x of b is just going to be equal to pi minus xa, because that was xa, and to get to xb, so that's some distance xa, and then you just go to pi, and then you go back xa steps. And so that's equal to 2.475. But they want the coordinates, both of them. So you just go yb is equal to, say, the cosine of xb, because you know it lies on that cosine line, which is minus 0.786. And let's just look at the diagram to see if that makes sense. X is positive, y is negative. That looks like it's probably going to be correct. Question 6. So we have some vectors, and we are already told basically what to do is to use the scalar product. So that's also known as the dot product, as opposed to the cross product. And they want us to use it to find an angle. And if they just asked us to find an angle, we would know to use the dot product anyway. So let's do that. So if you think about, let's say these are our 3 points. this is not to scale, this is not realistic or anything, but just to get a picture. If we want the angle OAB, we need to be dotting OA and AB. So if we think about BA, the line from B to A, well, that's just going to be A minus B. And we've been over before why that is true. So if we work that out, we get that it's minus 5 minus 1, 2. So if we have OA dot BA, this is going to be, you just multiply the elements element-wise. So it's minus 10 plus 3 plus 10, which is minus 3. And this is also should be equal to the magnitude of OA times the magnitude of BA times the cosine of the angle between them. Well, the magnitude of OA, it's like Pythagoras, you just square the elements. So that's 2 squared plus 3 squared plus 5 squared multiplied by 5 squared plus 1 plus 2 squared, or multiplied by cosine of theta. And if you solve this and plug it into your calculator, you get the theta is 95.1 degrees. Okay, so now they want us to use those same vectors to find the area of this triangle. So you're not really told much about this triangle. I mean, you could try and find out where the angles are, or you could just think of it as the area of triangle OAB. It's 1/2 times base times height, and you can pick what you decide the bases are and the height is, but it's going to be 1/2. Let's say our base is OA. Well, that means that the height is going to be BA sine of theta. So for example, if our triangle looked like this, oops, and that's A, that's O, that's B, then the base is obviously OA, the magnitude of OA, and this is our angle theta, and then this height H is going to be equal to the hypotenuse of this bigger triangle times the sine of theta. And you can plug in all the numbers and get the solution. Okay, question 7. So we're looking at a function f here. And the first task is just to differentiate it a couple of times. So this is pretty easy. F prime of x, you just use the chain rule. 3/2 comes down, 4x plus 1, and this exponent goes down by 1, giving us 1/2. And then you multiply it by the derivative of whatever's inside, and the derivative is just 4. So this is equal to 6 times 4x plus 1 to the 1/2. And then we do exactly the same thing again, but we now do it to this guy. A 1/2 comes down, giving 3 times 4x plus 1 to the minus 1/2, multiplied by the derivative of what's inside, which is 4. Okay, so now we're told we have some progression S, and it looks like this: f of 2. So that's going to be 9 to the 3/2, plus f prime evaluated at 2, which is 6 times 9 to the 1/2, plus k times f prime prime evaluated at 2, which is going to be 12 over 9 to the 1/2, plus blah, blah, blah. And so this is equal to, I'm just going to put it in terms of 3s, 3 cubed plus 6 times 3 plus 12 on 3k, plus blah, blah, blah. And we know that it's a geometric progression, and this means that there is some initial value, a0, which is equal to 3 cubed, and that each each successive thing is just the previous one multiplied by something. So we know that A1 divided by A0 is equal to some constant R, which is the same thing as A2 divided by A1. So A1 divided by A0 is 6 on 9. And A2 divided by A1 is 2K on 9. And so you can see straight away that K must be equal to 3. Okay, question 8. So we've given a couple of functions here, f and g. And the first question is firstly asking us to recognize that gf of x is the same thing as g of f of x. So you can kind of string functions together by just concatenating the letters which symbolize them. So let's do that. So g of f of x, wherever you see an x in the g function, you've plugged the whole of f of x. So it's going to be 3 times f of x, which is 2x squared plus 3, all plus 2. And it's pretty straightforward to see that that's going to give you 6x squared plus 11. And they want an unsimplified expression for fg of x. Fg of x, which is f of g of x. Now, wherever you see x in the f expression, you put the whole of g. So it's 2 times 3x plus 2 all squared plus 3. And they say unsimplified, so that you can just leave it like that. Okay, so now they want an expression for the inverse of fg. So let's call fg of x, let's call that y. And so that's equal to what we had before, which is 2 times 3x plus 2 all squared plus 3. And if you rearrange this, you get that you have 3x plus 2 is equal to, plus or minus square root of 1/2 y minus 3. And you have to have only one root here, otherwise it can't be an inverse function because it's going to be 2 to 1. And so we're going to take the positive root here because x has to be greater than or equal to 0. If you look back up here, you see that the f and g are only defined when x is greater than or equal to 0. So therefore, you can only take the positive root. Yeah? And if you solve a bit further, you get x is equal to 1/3 times the square root of 1/2 times y minus 3 minus 2. And then you relabel, and that's how you switch. So you get x in terms of y, and then you say, okay, I'm just going to relabel x and y now, because so this thing is basically fg inverse of y, and I want fg inverse of x, but I mean, I just relabeling x and y. They're all arbitrary anyway. I could call them t or, h or whatever it is that I want. And so that's 1/3 square root 1/2 x minus 3 minus 2. And now they want the domain of this inverse function. Well, the domain of some function f inverse is equal to the range of f. So what's the range of f? Well, sorry, our f is fg. So range of fg, x starts at 0. So this is the smallest value this thing can be is 0 because x just enters as a positive. So that's 2 times 2 squared plus 3 is equal to oh wait, actually, you know what? That, yeah, 2 times 2 squared plus 3. Should that be? Oh, right, we want the range of f. Times 2 squared. Is that correct? Oh, you know what? This is actually like a bad way to do it. So what I will instead do Okay, it's not letting me do that. Sorry, that really is a bad way of thinking about it. So instead, what I'm going to do is think about the range of the functions individually. So the range of G. So x has to be bigger than 0, right? So if you look back up to what G was, G will range from 2 to infinity. So in x is 0, G is 2, and then x can just keep increasing forever, and G will just keep increasing. So this is going to be greater than or equal to 2 and less than or equal to infinity. And therefore, the range of f g of x, well, if we look at fg, the smallest this thing can be is this input can be is 2. Wait, no, we're looking at f. So yeah, okay, it does work out the same. So the smallest this can be is 2 times 2 squared, which is 8 plus 3, which is 11, and smaller than or equal to infinity. Sorry, the first way I was doing it would actually have given you the right answer. So you can also think of going straight into FG, or you can think about it as finding out what the ranges of G are and then plugging them into F as well. So this would have given you a minimum of 2, which would have then gone into here as a minimum of 2. 2 times 2 squared plus 3 is exactly the same as what it was. So that gives you the solution for the domain. Domain of fg minus 1 of x is greater than or equal to 11 and less than or equal to infinity. Okay, one last piece of this question. Now we've got to solve gf of 2x equals fg of x. So gf of 2x is 6 times 2x squared plus 11, which is equal to fg, which is fg of x, which is 3x plus 2 squared plus 3. So we get 24x squared minus plus 11 equals 2 times this quadratic, 9x squared plus 12x plus 4, all plus 3. So we have 6x squared minus 24x is equal to 0. X minus 4 is equal to 0. So x is equal to 0 or x is equal to 4. And both of these are allowed because all we know is that x has to be greater than or equal to 0. And both of these fulfill that. Okay, question 9. We're given the equation of a curve, and we're asked to find the equation of the tangent to the curve at this point. So the curve is doing some parabola stuff, and we're given some particular point, and we want the equation of the tangent. So the first thing we know is that the gradient of a tangent at a point is equal to the gradient of the curve at that point. I mean, that's what defines the tangent. So dy dx evaluated at a, if we just differentiate it, it gets us 2x minus 2 evaluated at a, and a has x equals to 2, so this is equal to 2. And this is the gradient of our tangent curve. So we have that y is equal to 2x plus c. We plug in the point A. We know it has to pass through the point A. It's the tangent. So that gives us that 2 is equal to 4 plus c, or c is equal to minus 2. So the final thing is the equation is y is equal to 2x minus 2. This is a pretty simple procedure, and we'll be repeating it a few times in this question. So now they're telling us that the normal to the curve at A intersects the curve again at B. Find the coordinates of B. So we know that the normal has a gradient such that it's basically minus 1 over the gradient of the previous one. So it's going to be minus a half here, because it's perpendicular to the curve, to tangent, so it must have a gradient of -1 over the gradient of the tangent. And again, we know that the normal is at A, so it must pass through A. So you can plug that in. So 2 is equal to -1 plus C, gives us C is equal to 3, C normal. So that means the equation of the normal is equal to -1/2 x plus 3. And now we solve simultaneous equations, because we know that this thing, it intersects the curve at A, but it also intersects it at B. So we can set the y values equal to each other. So we get -1/2 x plus 3 is equal to the equation of the curve, x squared minus 2x plus 2. And this is the same thing as an equation of 2x squared minus 3x minus 2 is equal to 0. And I'm going to factorize that as 2x plus 1, x minus 2. And this has roots at x is equal to 2, that was the one at A that we already know about. And this other one, x is equal to -1/2, and that's the other root, in which case y is equal to 13 on 4. So the coordinates of B are -1/2, 13 divided by 4. And now we're told that the tangents at these 2 points intersect each other at C. So let's first find we already have the equation of the tangent at A. That was y is equal to 2x. Now let's up with this pen. 2x minus 2. And now we want to find let's find the equation of the tangent at B. dy dx evaluated at B. And we know what B is, so that's -1 minus 2, which is equal to -3. And so this is equal to the gradient of the tangent at B. We know that it must pass through B. So we get that 3/4 is equal to 3/2 plus C. And that gives us that C, this is just the constant C, not the point C. So CB is equal to 7/4. So that means that the equation of the tangent at B is equal to -3x plus 7/4. Okay, we're almost done. They intersect. This one intersects the other equation at C, so we can set them equal to each other. So we have 2x minus 2 is equal to -3x plus 7/4. And you will see that this gives you an x value of 3/4. And then you plug it back into one of the equations we're looking at, say this one, and you get that y is equal to -1/2. Phew! And we're done. So you see we had to do this whole constructing the equations from the information we knew a bunch of times, but we got there in the end. Okay, question 10. This is an integration question. So our first task is to find the coordinates of this turning point of the curve. So that's pretty easy. We know that the turning, the minimum is given where the first derivative is equal to 0. So we have that 2x minus 2 over x squared is equal to 0. Multiply both sides by x squared, we get that, 2, and divide by 2, we get that x cubed minus 1 is equal to 0. And x is equal to 1 will solve that equation. So that's the x coordinate of A. And now they want us to integrate to find that the original function f of x. So we know f prime of x. So we're going to integrate. So dy dx is 2x minus 2 over x cubed. And now we're going to separate variables. So we have dy is equal to 2x minus 2 over x cubed dx. And we're going to integrate this to get y is equal to, is equal to x squared plus 1 over x cubed, and convince yourself, plus some constant, and convince yourself that if you differentiated this, you would get that back. And now we need a point on the curve in order to get this constant. Well, if we look at the curve, we're told in the question that there is this point for 189 over 16, so you can just plug that in. So plug in for 189 over 16, and that solves for c, and that'll give you the full equation. Y is equal to x squared plus 1 over x squared minus 17 over 4. Okay. Now we need to find the x coordinates of b and c. Well, if we look at b and c, we see they are the roots of this equation. So we know that f of x is equal to 0 at those points. So that gives us that the f of x that we found, which is x squared plus 1 over x squared minus 17 over 4, is equal to 0. And we multiply through by, so we times by x squared to get rid of the thing on the denominator. And we get that x to the 4th plus 1 minus 17 over 4 x squared is equal to 0. So we can solve this. This is actually, it doesn't look like a quadratic because you got an x to the 4th, but it's actually a quadratic in x squared. So if we think of x to the 4th as x squared squared, we can solve for x squared using the formula. So x squared is 17 over 4 plus or minus square root 17 over 4 all squared minus 4 times 1 all over 2, which is 17 plus or minus 15 over 8. And so this is equal to either 4 or 1 over 4. Now, if we then want to solve for x, well, it's pretty easy. We get x is either equal to square root of 4, which is 2, or x is equal to 1/2. And we know we can take the positive roots here just to clarify, because we can see from the graph that x is greater than 0. Okay, now they want us to find the area of the shaded region. This is the last bit. Well, you just integrate the function to find the area under a curve. So the area is going to be the integral of f of x dx from b to c. So if we look again at the picture, you'll see that you're integrating between here and here, from b to c. And so this is going to be the integral from the x, whatever x is at b, which is 1/2, to the x value at c, which is 2, of the function f of x, which is x squared plus 1 over x squared minus 17 over 4 dx, which is going to be 1/3 x cubed minus 1 over x times 1/2 minus 17 over 4x, all evaluated between 1/2 and 2. And you can plug that in to get the solution. And there we go. That's all done. I hope that was helpful for you guys. Let me know if you have any questions on the forums, and I'll see you next time. Bye.